The morning of June 6th, 1816, should have brought the warmth of early summer to New England. Instead, Sarah Whitmore pulled her woolen shawl tighter as she stepped onto her farmhouse porch in Vermont, her breath forming clouds in the bitter air. Snow dusted the ground where green shoots should have been reaching toward the sun. Behind her, the embers in the fireplace crackled a fire that had burned continuously since April, when winter refused to release its grip on the world. "Mother, the chickens won't leave the coop," her 12-year-old son Thomas called from the yard, his voice carrying an edge of fear that had become all too familiar. The boy had grown thin over the past months, as had they all. The root cellar, which should have lasted until the harvest, was nearly empty. Sarah nodded grimly and turned her gaze eastward, toward the orange-tinted horizon that had haunted their skies for months. The sun, when it appeared at all, hung pale and weak, behind a veil of strange, persistent haze that stretched from horizon to horizon. Something was terribly wrong with the world, and nobody could explain what. What Sarah and millions of others across the globe didn't know was that their suffering had begun exactly 1 year earlier, and half a world away, on a volcanic island in the Dutch East Indies called Tambora. On the evening of April 10th, 1815, British colonial administrator Sir Stamford Raffles was reviewing trade documents in his residence in Java when the ground beneath his feet began to tremble. At first, he dismissed it as another minor earthquake. The islands of the Indonesian archipelago were notorious for their seismic activity, but as the minutes passed, the trembling intensified into violent shaking that sent books tumbling from shelves and cracked the walls of his study. "Sir Stamford," his aide burst through the door, his face pale with alarm. "The harbor master reports ships fleeing from the direction of Sumbawa. They speak of fire in the sky and walls of water." Raffles rushed to his window and peered into the darkness. To the east, an ominous red glow painted the horizon, pulsing and flickering like the breath of some massive dragon. The sound that reached them was unlike anything in human experience, a continuous, thunderous roar that seemed to emanate from the very bowels of the earth. On the island of Sumbawa, where Mount Tambora had slumbered for centuries, the mountain was dying in the most spectacular and devastating way imaginable. The explosion that began that night would be heard across an area larger than Europe. In Batavia, over 800 miles away, the Dutch governor would mistake the sound for naval gunfire and send ships to investigate a battle that existed only in the fury of the earth itself. But the true horror was only beginning. As the mountain disintegrated, it hurled an estimated 38 cubic miles of rock, ash, and debris into the atmosphere, enough material to bury the entire state of Rhode Island under 12 feet of stone. The volcanic column rose nearly 30 miles into the sky, punching through the stratosphere and injecting millions of tons of sulfur dioxide into the upper atmosphere. Captain James Phillips of the merchant vessel Elizabeth was sailing the Java Sea when the eruption reached its peak. His log entry, written in a shaking hand by lamplight in his cabin, would later become one of the most haunting first-hand accounts of the disaster. "The sun has vanished entirely. At noon, the darkness is so complete that I cannot see my hand before my face. The crew speaks in whispers of the end of the world, and I confess I cannot offer them reassurance. The sea boils with floating pumice, and the air burns our lungs with each breath. Lightning flickers continuously in the volcanic cloud above, illuminating shapes that no Christian man should witness. We sail by compass alone through what I can only describe as hell itself." The immediate devastation was apocalyptic. The Indonesian archipelago, home to millions, was transformed into a wasteland. Entire islands disappeared beneath tsunamis triggered by the collapse of the volcanic mountain. Others were buried under layers of ash so thick that they would remain uninhabitable for years. Conservative estimates put the immediate death toll at 71,000 people. But the true number would never be known. Entire communities were simply erased from existence. Yet this regional catastrophe was only the beginning of a global disaster that would unfold over the following months with methodical, relentless cruelty. Dr. Heinrich Brandes, a meteorologist in Breslau, Prussia, had been meticulously recording weather observations for over a decade. By the summer of 1815, he began noting anomalies in his data that defied explanation. Atmospheric pressure readings fluctuated wildly. Temperature measurements showed bizarre patterns, summer days that felt like autumn, followed by brief periods of normal warmth, then sudden drops that brought frost in July. The atmosphere appears to be in rebellion against the natural order, he wrote to a colleague in Berlin. I have observed phenomena that my training cannot explain. The sunset yesterday was the color of dried blood, and the stars, when visible through the haze, flicker with an unnatural light. What Dr. Brandis was witnessing was the beginning of the most severe climate anomaly in recorded human history. The sulfur dioxide ejected by Tambora was combining with water vapor in the stratosphere to form microscopic droplets of sulfuric acid. These aerosol particles, suspended high above the weather systems, were creating a global veil that reflected sunlight back into space before it could warm the Earth's surface. The effects were not immediately apparent. The particles took months to spread globally on stratospheric winds, and their impact on weather patterns was gradual but inexorable. As winter approached in late 1815, many regions experienced unusually severe cold, but few connected these local weather variations to events on the other side of the world. By spring of 1816, however, the global nature of the crisis became undeniable. In Switzerland, Mary Wollstonecraft Godwin, who would later become famous as Mary Shelley, was staying at Villa Diodati, near Lake Geneva, with her lover Percy Shelley, her stepsister Claire Claremont, and the infamous poet Lord Byron. They had planned a summer of literary collaboration and romantic adventure on the shores of the beautiful alpine lake. Instead, they found themselves prisoners of what Byron would later describe as the wet, ungenial summer. Day after day, cold rain lashed the villa while unnatural twilight shrouded the landscape. The lake, normally a brilliant blue, appeared gray and forbidding under skies that seemed perpetually on the verge of storm. Confined indoors by the relentless weather, the group began telling ghost stories to pass the time, a diversion that would eventually inspire Mary to write Frankenstein, her tale of scientific hubris and unnatural creation that seemed to mirror the unnatural world outside their windows. Byron, ever the romantic, saw apocalyptic poetry in their predicament. In his journal, he wrote, "The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air." These lines would later appear in his poem Darkness, one of the most haunting literary works inspired by the crisis. But for most people, the situation was far less romantic. Across Europe, crops failed catastrophically. The summer growing season simply never arrived. In France, wheat harvests dropped to less than half their normal yield. In Germany, food riots broke out in major cities as bread prices soared beyond the reach of ordinary citizens. The Irish, already struggling with poverty and political oppression, faced mass starvation as potato crops rotted in the cold, wet ground. In North America, the situation was equally dire. Farmers in New England and eastern Canada watched helplessly as their crops withered in the persistent cold. Snow fell in every month of the year, earning 1816 the nickname "the year without a summer," or, more ominously, 1800, and froze to death. The crisis created waves of migration that would reshape the continent. Unable to sustain themselves on their failing farms, thousands of New England families loaded their possessions into wagons and headed west, seeking more hospitable climates and fertile land. This exodus would accelerate the settlement of the Ohio River Valley and contribute to the rapid expansion of the American frontier. But perhaps nowhere was the suffering more acute than in China, where the Tambora winter triggered one of the most devastating famines in human history. Li Wei, a rice farmer in the Yunnan province, had worked the same terraced fields that his ancestors had cultivated for generations. The rhythms of planting and harvest were as familiar to him as his own heartbeat until the year when the rains never came, and then came too much, and the sun disappeared behind an endless gray veil. His village had survived floods and droughts before, but nothing like this. The rice paddies, which should have been emerald green with growing grain, were muddy wastelands filled with rotting vegetation. The few crops that survived the cold were destroyed by unprecedented flooding as disrupted weather patterns brought torrential rains at the wrong seasons. "The mandate of heaven has been withdrawn," the village elder declared as they gathered what little grain remained from their stores. "The spirits of the earth and sky are at war." Li Wei didn't understand the politics of celestial mandates, but he understood hunger. As winter approached, families began the terrible calculus of survival: which children to feed, which elderly relatives could be sustained, who might survive if they abandoned their homes and joined the desperate migrations toward regions rumored to still have food. The Chinese famine of 1816 to 1817 would ultimately claim the lives of millions. Entire regions were depopulated as communities collapsed and social order broke down. The Qing dynasty, already facing internal pressures, found its legitimacy questioned as subjects wondered what cosmic crime had brought such suffering upon the empire. The global scope of the disaster was particularly remarkable because it occurred in an age when most people lived their entire lives within a few miles of their birthplace. News traveled slowly, carried by ships and horseback riders across vast distances. Yet the effects of Tambora were so pervasive that even isolated communities found themselves struggling against the same invisible enemy. In India, the disruption of monsoon patterns triggered crop failures and famine. In the Ottoman Empire, unusual weather destroyed harvests and contributed to political instability. Even in regions that escaped the worst agricultural disasters, the economic ripple effects were severe, as global trade networks strained under shortages and price shocks. Yet for all its devastation, the year without a summer also revealed the remarkable adaptability and ingenuity of human civilization. In Vermont, farmer William Jarvis watched his traditional crops fail, but noticed that some cold-weather plants seemed to thrive in the altered climate. He began experimenting with new varieties of grains and vegetables, developing agricultural techniques that would prove valuable for future farming in harsh conditions. His innovations would later contribute to the development of hardier crops that could withstand temperature extremes. Across New England, communities came together in ways that transcended traditional social boundaries. Wealthy merchants shared their food stores with struggling farmers. Churches organized relief efforts that crossed denominational lines. Neighbors who had feuded for years worked together to ensure that children and the elderly didn't starve. The crisis also accelerated technological innovation. In Germany, Karl Dreis invented the running machine, an early predecessor of the bicycle, partly in response to the death of horses from starvation and the need for alternative transportation. In Scotland, macadam roads were developed to improve transportation of food supplies to struggling communities. Perhaps most significantly, the global climate crisis began to change how people thought about their relationship with the natural world. For the first time in human history, a generation experienced firsthand evidence that natural systems could change rapidly and dramatically, affecting every aspect of human civilization. Scientists across Europe and North America began collaborating in unprecedented ways, sharing weather observations and trying to understand the mechanisms behind the climate anomaly. This early international scientific cooperation would eventually lead to the development of modern meteorology and climatology. Alexander von Humboldt, the great German naturalist, was among the first to recognize that the unusual weather might be connected to volcanic activity. He had observed the eruption of Galeras in Colombia in 1801 and noted temporary local climate effects. His detailed documentation of atmospheric conditions during 1816 would later provide crucial evidence for understanding the relationship between volcanic eruptions and global climate. As 1817 dawned and the atmospheric veil finally began to dissipate, the immediate crisis started to ease. The sun, no longer filtered through sulfuric acid droplets, began to warm the earth normally. Growing seasons returned to their natural patterns. Harvests slowly recovered, though it would take years for food supplies to return to normal levels. But the world that emerged from the Tambora winter was fundamentally different from the one that had entered it. The massive population migrations triggered by the crisis had reshaped settlement patterns across continents. New communities had been established, while others had been abandoned forever. Political boundaries had shifted as governments rose and fell under the pressure of feeding their populations. The experience had also planted the seeds of new ideas about human civilization's vulnerability to environmental change. Writers and thinkers began exploring themes of natural catastrophe and social collapse that would influence literature and philosophy for generations. Most immediately, the crisis had demonstrated the interconnectedness of global systems in ways that previous generations could never have imagined. A volcanic explosion on a remote Indonesian island had affected farmers in Vermont, poets in Switzerland, and peasants in China. The modern concept of global environmental change was beginning to take shape in human consciousness. Dr. Heinrich Brandes, still meticulously recording his weather observations in Prussia, noted in his journal as normal temperatures returned. We have witnessed something unprecedented in human memory, a year when the very climate itself seemed to abandon the natural order. Future generations may face similar trials, and they must be better prepared than we were. His words proved prophetic. The lessons learned during the year without a summer would inform later responses to natural disasters and climate variations. The international scientific cooperation that began during the crisis would evolve into modern global monitoring systems that track volcanic activity, atmospheric changes, and climate patterns. The agricultural innovations developed during the food crisis would contribute to the development of more resilient farming practices. The social cooperation networks that emerged in struggling communities would serve as models for disaster relief organizations that continue to operate today. Perhaps most importantly, the Tambora winter demonstrated humanity's remarkable capacity for adaptation and survival in the face of unprecedented challenges. Communities that had never faced such extreme conditions found ways to endure. Families separated by migration found ways to reunite. Economies devastated by crop failures found ways to rebuild. As the last of the atmospheric haze finally cleared in late 1817, and the sun once again shone with its full strength on a healing world, survivors looked back on their ordeal with a complex mixture of trauma and pride. They had lived through what many had believed to be the end of the world and emerged with a deeper understanding of both human vulnerability and human resilience. The frozen hell of 1816 had been caused by a single mountain's death scream, but it had revealed truths about human civilization that would resonate far beyond the temporary veil of volcanic ash. In the face of global catastrophe, people had discovered not just their capacity for suffering, but their capacity for adaptation, cooperation, and hope. The year without a summer had ended. But its lessons would echo through history, a reminder that the natural world holds powers beyond human control, and that our survival depends not just on the stability of our environment, but on our ability to come together when that stability fails. In the decades that followed, as normal weather patterns returned and the immediate memory of the crisis began to fade, some dismissed the Tambora winter as a freak occurrence unlikely to ever repeat. But others, including those who had lived through the cold and hunger and fear, understood that they had witnessed something more significant, a preview of the kinds of challenges that human civilization might face again. Mount Tambora itself slowly rebuilt, as volcanoes do, its slopes gradually healing under new vegetation. But deep beneath the earth, the same forces that had once frozen the world continued their restless movement, a reminder that our planet's climate is far more fragile and changeable than most people dare to imagine. The frozen hell of 1816 had been temporary, but the knowledge it brought was permanent in our interconnected world. The actions of one part of the earth can affect all others, and our survival depends on our ability to understand, prepare for, and respond to changes that can reshape the very foundations of human civilization. 0836. The lessons of 1816 would prove more prescient than anyone could have imagined. As the decades passed and the immediate trauma faded from living memory, the world began to forget the vulnerability that Tambora had revealed. But deep in the archives of scientific institutions across Europe and America, the careful observations recorded during those terrible months continued to yield insights that would reshape humanity's understanding of its place in the natural world. In London, the Royal Society had compiled thousands of pages of weather observations, temperature readings, and atmospheric measurements from correspondents across the British Empire. Dr. Luke Howard, the meteorologist who had coined the modern system for classifying clouds, spent years analyzing this unprecedented data set. What he discovered would fundamentally alter scientific thinking about climate. The evidence is incontrovertible, he wrote in his landmark 1823 paper, on the influence of volcanic eruptions upon global atmospheric conditions. The eruption of a single mountain in the Indies has demonstrably altered weather patterns across the entire globe. We can no longer think of climate as a collection of local phenomena, but must understand it as a single, interconnected system of extraordinary complexity and delicate balance. Howard's work was revolutionary not just for its scientific insights, but for its implications about human civilization's relationship with the natural world. For the first time, scientists began to understand that the Earth's climate was a unified system that could be dramatically altered by single events, no matter how distant. This realization came at a particularly crucial moment in human history. The Industrial Revolution, which had been gathering momentum throughout the late 18th century, was beginning to transform the world at an unprecedented pace. Steam engines were replacing water mills. Coal was becoming the primary fuel for manufacturing. Cities were growing explosively as people abandoned agricultural life for factory work. James Watt's improved steam engine, patented just decades before Tambora's eruption, was now powering textile mills across Britain. Coal consumption was rising exponentially as factories operated around the clock to meet growing demand for manufactured goods. The age of fossil fuel consumption had begun, though few understood its ultimate implications. In Manchester, the heart of Britain's textile industry, factory owner Robert Owen was among the first to recognize the connections between industrial activity and environmental change. He had witnessed the choking smoke that poured from hundreds of factory chimneys, turning the sky gray even on clear days. He had seen how the rivers that powered the mills became polluted with chemical runoff, killing fish and making the water undrinkable. "We are conducting an experiment upon the atmosphere itself," Owen wrote to a colleague in 1824. "Just as the volcano in the Indies altered the very air we breathe, so too do our engines and furnaces. The question is not whether we are changing the climate, the question is how much change we can cause before we face consequences as severe as those witnessed during the year without a summer." Owen's concerns were prescient, but they were largely ignored by his contemporaries. The immediate benefits of industrialization, increased production, growing wealth, and technological marvels that seemed to give humanity unprecedented control over the natural world overshadowed worries about long-term environmental consequences. The memory of Tambora's devastation was fading, and with it, the hard-won understanding of human vulnerability to climate change. A new generation was rising that had not experienced the fear and hunger of the frozen year, and they embraced the promise of industrial progress with enthusiasm unconstrained by environmental concerns. Yet across the world, the effects of the Great Eruption continued to reverberate in ways both obvious and subtle. The massive migrations triggered by crop failures had reshaped entire continents. In North America, the westward movement of New England farmers had accelerated the displacement of Native American tribes and the expansion of European settlement patterns. Towns and cities that might never have existed were founded by climate refugees seeking new homes in more hospitable regions. The economic disruptions had similarly lasting effects. Traditional trade relationships had been shattered when entire regions could no longer produce their customary exports. New commercial networks had emerged to replace them, often following very different geographic and political patterns. The global economy that emerged from the Tambora crisis was fundamentally different from what had existed before. Perhaps most significantly, the shared experience of global climate catastrophe had begun to create new forms of international cooperation. The exchange of weather observations and scientific data across national boundaries during the crisis had established precedents for international collaboration that would eventually evolve into formal institutions for global environmental monitoring. In Germany, Alexander von Humboldt had spent the years since 1816 developing what he called a cosmic understanding of natural systems. His extensive travels and careful observations had convinced him that the Earth's climate, geology, and biology formed an integrated whole that could only be understood through comprehensive, international scientific cooperation. "The atmosphere knows no political boundaries," Humboldt wrote in his influential work, Cosmos. "A volcano in the Indies affects the wheat harvest in Prussia. The forests of the Amazon influence the rains of Europe. We live not on separate nations carved from the earth, but on a single planet whose systems are so interconnected that the health of any part affects the health of all." Humboldt's holistic vision of planetary systems would inspire generations of scientists and ultimately contribute to the development of modern Earth system science. But in his own time, such thinking was revolutionary and often dismissed as too theoretical to have practical value. The practical value became apparent sooner than skeptics expected. In 1835, another major volcanic eruption occurred, this time at Cosiguina, in Nicaragua. Scientists who had studied the Tambora event were prepared to observe and document the atmospheric effects with unprecedented precision. Weather stations across the Americas and Europe coordinated their observations, creating the first truly global monitoring network for volcanic climate impacts. The Cosiguina eruption was smaller than Tambora, but its effects were still significant enough to cause crop failures and unusual weather across much of the northern hemisphere. However, this time, governments and communities were better prepared. Early warning systems allowed farmers to adjust their planting schedules. International food trade networks that had developed since 1816 provided alternative supply sources when local crops failed. The disaster was still severe, but the death toll was far lower than it might have been without the lessons learned from the year without a summer. Dr. Samuel Morse, who was developing his telegraph system during this period, recognized the crucial importance of rapid communication for coordinating responses to global environmental crises. The same networks that carry news of commerce and politics, he argued, must also carry warnings of atmospheric disturbances and climate anomalies. The speed of communication may determine whether thousands live or die when the next great volcano speaks. Morse's telegraph lines, spreading rapidly across continents by the 1,840 seconds, would indeed become crucial tools for environmental monitoring and disaster response. Weather observations that once took months to share between distant locations could now be transmitted in minutes. The first primitive weather forecasting services emerged, using telegraph networks to track storm systems and atmospheric changes across vast regions. But as communication and monitoring improved, so did the scale of human impact on the environment. The same industrial revolution that was providing new tools for understanding climate was also creating new ways to alter it. In Pennsylvania, the anthracite coal fields were producing unprecedented quantities of fuel for the growing industrial economy. Coal-burning locomotives were revolutionizing transportation, carrying goods and people across continents in a fraction of the time required by horse-drawn vehicles. Coal-powered steamships were making ocean travel faster and more reliable, knitting together a truly global economy for the first time in human history. The environmental costs of this transformation were becoming increasingly apparent to careful observers. In the industrial cities of Britain, air pollution was reaching levels that affected human health on a massive scale. In London, coal smoke was so thick during winter months that it created a perpetual twilight, reducing visibility to just a few feet, and contributing to respiratory diseases that killed thousands annually. The environmental degradation was not limited to the immediate vicinity of factories and cities. Coal mining operations were stripping entire landscapes bare, leaving behind poisoned waterways and barren hillsides. Deforestation to provide timber for construction and fuel was accelerating as populations grew and industrial demand increased. By the 1,850 seconds, a few scientists were beginning to wonder whether human industrial activity might be capable of affecting global climate in ways similar to major volcanic eruptions. The quantities of coal being burned were producing atmospheric pollution on a scale that had never before been seen in human history. Could human beings be inadvertently conducting the same kind of atmospheric experiment that Tambora had imposed on the world? The question became more urgent as the scale of industrialization continued to expand. The California gold rush of 1849 had triggered a new wave of resource exploitation that spread across the American West. Railroad construction was accelerating, requiring enormous quantities of coal to power the locomotives and iron to build the tracks. The Civil War of the 1,860 seconds would demonstrate industrial warfare on a massive scale, consuming resources and producing pollution at rates that dwarfed previous human conflicts. In Europe, the pace of industrial growth was equally dramatic. Germany was emerging as a major industrial power, its coal mines and steel mills producing goods that competed with British manufacturers. France was rebuilding Paris with grand boulevards and modern infrastructure that required unprecedented quantities of materials and energy. Russia was beginning its own industrial transformation, exploiting the vast natural resources of Siberia to fuel economic development. The interconnectedness that had been revealed during the Tambora crisis was becoming even more pronounced as global trade networks expanded and deepened. Raw materials extracted in one continent were processed in another and consumed in a third. Environmental changes in any major region could now affect economic and social conditions across the entire world. This interconnectedness became dramatically apparent during the Irish potato famine of the 1,840 seconds. Like the Tambora crisis, the famine was triggered by environmental factors, in this case, a fungal disease that destroyed potato crops across Ireland. But the severity of the disaster was greatly amplified by political and economic structures that had developed since 1816. Ireland's heavy dependence on potato cultivation had been partly shaped by the agricultural disruptions of the year without a summer. The potato had proven to be one of the more reliable crops during the climate crisis, leading many Irish farmers to specialize even more heavily in potato farming. When the blight struck, entire communities had no alternative food sources. The British government's response to the famine was influenced by new economic theories that emphasized free market solutions and minimal government intervention, ideas that had gained popularity, partly as a reaction to the extensive government involvement in food distribution during the Tambora crisis. The result was a disaster that killed over 1 million people and forced millions more to emigrate, fundamentally altering the demographic and political landscape of both Ireland and the countries that received Irish refugees. The potato famine demonstrated how environmental, political, and economic systems had become so intertwined that disruptions in one area could cascade through all others with devastating consequences. The lesson was not lost on observers who remembered the global scope of the Tambora disaster. Charles Darwin, who had experienced the aftermath of Tambora during his youth and later traveled the world observing how environmental changes affected living systems, began developing theories about the relationship between environmental change and evolution. His observations during the voyage of the Beagle had shown him how volcanic activity, climate variations, and other environmental factors could drive rapid changes in plant and animal populations. The climate of the Earth is not a stable backdrop against which life evolves, Darwin wrote in his notebook. Rather, it is an active force that shapes the very process of evolution itself. The great eruption of the Indies showed us that climate can change rapidly and dramatically, and when it does, only those organisms capable of adapting quickly will survive. Darwin's insights about adaptation and survival would prove relevant not just to understanding biological evolution, but to understanding how human societies might need to evolve in response to environmental challenges. The societies that had survived and thrived after the Tambora crisis were those that had developed greater flexibility, stronger cooperation networks, and more diverse economic foundations. As the 19th century progressed, these lessons became increasingly relevant. The industrial transformation was creating new forms of environmental stress that required adaptive responses from human communities. Air and water pollution were creating health challenges that required new approaches to urban planning and public health. Resource depletion was forcing the development of new technologies and more efficient production methods. The telegraph networks that had emerged partly in response to the need for better communication during environmental crises were now carrying information about new forms of environmental change. Reports of forest destruction, species extinctions, and pollution were being transmitted across continents, creating the first truly global awareness of human environmental impact. In 1859, the year Darwin published On the Origin of Species, another significant environmental event occurred that demonstrated humanity's growing power to alter natural systems. The drilling of the first successful oil well in Pennsylvania marked the beginning of the petroleum age, adding a new dimension to human environmental impact that would eventually dwarf even the effects of coal burning. The oil industry developed with remarkable speed, driven by the enormous economic advantages of liquid fuel for transportation and manufacturing. Within decades, oil-powered ships were replacing sail-powered vessels on the world's oceans. Petroleum-based lubricants were making possible new kinds of machinery with unprecedented precision and efficiency. Kerosene was providing lighting that extended productive hours and transformed social patterns in cities and rural areas alike. But those who remembered the lessons of Tambora recognized that this new source of atmospheric emissions represented a potential threat on a scale that humanity had never before created. Unlike volcanic eruptions, which were sporadic and unpredictable, human industrial activity was continuous and accelerating. The quantities of carbon dioxide being released into the atmosphere were growing exponentially as coal and oil consumption expanded. The first scientists to seriously investigate the potential climate effects of industrial emissions were often dismissed as alarmists or theoretical speculators. The benefits of industrialization were so obvious and immediate that few people wanted to consider possible long-term costs. The memory of humanity's vulnerability to climate change, so vivid during the Tambora crisis, had faded as industrial progress seemed to give civilization unprecedented control over natural forces. Yet the scientific evidence was becoming increasingly clear to those who studied it carefully. By the 1,860 seconds, researchers had established that carbon dioxide in the atmosphere trapped heat from the sun, creating what would later be called the greenhouse effect. They had calculated that the quantities of carbon dioxide being released by human activities were large enough to potentially affect global atmospheric composition. The implications were profound but difficult for most people to accept. Industrial civilization had emerged partly as a response to the climate vulnerability revealed by Tambora. Yet that same industrial development might be creating an even greater climate threat. The tools that had been developed to protect humanity from natural climate variations might ultimately prove to be more dangerous than the natural threats they were designed to address. As the 19th century drew to a close, a few scientists and thinkers began to wonder whether humanity was unconsciously recreating the conditions that had made the year, without a summer, so devastating. But instead of a sudden shock from a distant volcano, the new threat would be gradual, persistent, and entirely of human making. The frozen hell of 1,816 had been caused by forces beyond human control, but it had revealed truths about planetary systems and human vulnerability that remained relevant as humanity gained the power to alter those same systems. The question facing the world as it entered a new century was whether the lessons learned during that terrible year would be remembered and applied before it was too late to prevent an even greater climate catastrophe, one caused not nature's fury, but by humanity's own unprecedented power to change the world. 0844. As the 20th century dawned, the industrial transformation that had begun in the wake of Tambora was accelerating at a pace that would have seemed impossible to the survivors of the frozen year. The world's population had more than doubled since 1816, and most of these new millions were concentrated in rapidly growing cities powered by coal and increasingly dependent on global supply networks that would have been unimaginable to previous generations. In the steel mills of Pittsburgh, immigrant workers from across Europe labored in conditions that transformed raw earth into the skeleton of modern civilization. The furnaces burned continuously, consuming trainloads of coal and ore, while producing the materials needed for skyscrapers, bridges, and the vast railroad networks that now connected continents. The smoke from these operations created permanent clouds that turned day into twilight across entire regions. Andrew Carnegie, whose steel empire had grown from the economic opportunities created by post-Tambora industrial development, stood in his Pittsburgh office watching the orange glow of the furnaces paint the night sky. At 70, he had lived through the transformation from a world where climate could be altered by distant volcanoes to one where human activity was beginning to rival natural forces in its ability to change the atmosphere itself. "We have become the masters of iron and fire," Carnegie wrote in his memoir. "Yet I wonder sometimes if we truly understand the power we have unleashed. The smoke that rises from our furnaces does not simply disappear, it joins with the very air that all humanity must breathe. We are conducting an experiment upon the earth itself, and unlike the volcano that froze the world in my youth, this experiment has no natural end." Carnegie's concerns were prescient, but they were overwhelmed by the extraordinary prosperity and technological progress that industrial development had brought. The same decade that saw his steel mills reach peak production also witnessed the first successful powered flight by the Wright brothers, the mass production of automobiles by Henry Ford, and the development of electric power systems that promised to eliminate the drudgery and darkness that had constrained human civilization for millennia. The Wright brothers' 12-second flight at Kitty Hawk in 1903 represented more than just a technological breakthrough. It symbolized humanity's growing mastery over natural forces. Within years, aircraft were being used for reconnaissance, mail delivery, and passenger transport. The development of aviation would eventually make possible global travel and communication on a scale that would have seemed magical to the climate refugees of 1,816. Henry Ford's assembly line production of the Model T automobile democratized personal transportation in ways that transformed society. By 1920, millions of Americans owned cars, reshaping everything from courtship patterns to residential development. The petroleum industry, which had begun with that first oil well in Pennsylvania, exploded to meet the demand for gasoline, creating new forms of wealth and new kinds of environmental impact. The electrification of cities eliminated much of the local air pollution that had plagued industrial centers, replacing coal-burning stoves and gas lamps with clean electric lighting and heating. Hydroelectric dams harnessed the power of rivers, while coal-burning power plants concentrated emissions in centralized facilities that seemed more manageable than the distributed pollution of countless individual furnaces. These technological advances created an illusion of environmental progress that masked the growing scale of humanity's impact on global systems. The pollution was becoming less visible in daily life. But it was not disappearing, it was being transformed and dispersed in ways that made its effects more difficult to detect and understand. The illusion was shattered by the first global conflict to be fought with industrial-age weapons and logistics. World War I demonstrated the terrifying efficiency with which industrial civilization could mobilize resources for destruction. The same steel mills that had built railroads and skyscrapers now produced artillery shells and poison gas. The same chemical industries that had created fertilizers and medicines developed new forms of chemical warfare. The war consumed resources and produced emissions at rates that dwarfed previous human activities. Entire forests were cut down to provide timber for trench works and fuel for military operations. Coal consumption reached unprecedented levels as nations mobilized their industrial capacity for total war. The atmospheric pollution from munitions, factories, steel mills, and transportation networks created regional climate effects that were noticeable even during the brief duration of the conflict. Captain Arthur Robertson, a British artillery officer who had studied the Tambora eruption as a young meteorology student, found himself calculating the atmospheric effects of the massive artillery bombardments that characterized trench warfare. In letters to his wife, he described the permanent haze that hung over the Western Front, created not by volcanic ash but by the smoke and dust of continuous industrial combat. "We have created our own volcanic winter," Robertson wrote from the Somme in 1916, exactly a century after the frozen summer. "The sun struggles to penetrate the cloud of our own making, and the earth trembles not from natural forces but from the ceaseless thunder of our guns. I fear we are learning to duplicate nature's most destructive powers, but without nature's wisdom about when to stop." The war's end in 1918 brought a brief period of optimism about humanity's ability to control and direct its technological powers for peaceful purposes. The League of Nations represented an attempt to create international cooperation that could prevent future conflicts and address global challenges. The rapid economic growth of the 1922 seemed to demonstrate that industrial development could provide prosperity for all without the need for destructive competition. But the decade also saw the emergence of mass consumption patterns that would fundamentally alter humanity's relationship with natural resources. The automobile culture that had begun with Henry Ford's Model T exploded into a comprehensive reshaping of American society around personal vehicle ownership. Suburbs sprawled outward from city centers, connected by networks of roads that required enormous quantities of concrete, steel, and asphalt. The petroleum industry expanded exponentially to fuel this transportation revolution. Oil fields in Texas, California, and the Middle East were developed with technologies that could extract fossil fuels from increasingly remote and difficult locations. The global economy became increasingly dependent on cheap, abundant oil, for everything from transportation to plastics to agricultural chemicals. Radio and early television broadcasting created the first truly global mass media, spreading consumer culture and industrial lifestyle patterns to every corner of the world. The same electromagnetic technologies that had enabled telegraph networks for weather monitoring were now carrying messages that encouraged maximum consumption and resource use. The environmental consequences of this transformation were becoming apparent to scientists who continued to study atmospheric changes. Carbon dioxide levels in the atmosphere were measurably higher than they had been before the Industrial Revolution, and the rate of increase was accelerating. Temperature measurements from around the world showed subtle but consistent warming trends that correlated with industrial emissions. Dr. Svante Arrhenius, the Swedish chemist who had first calculated the potential warming effects of atmospheric carbon dioxide, continued to refine his estimates as new data became available. By the 1920s, he was confident that human industrial activity was beginning to affect global climate in measurable ways. "We are witnessing the beginning of a great atmospheric experiment," Arrhenius wrote in 1925. "Unlike the eruption that darkened the world a century ago, this experiment is of our own making, and it will continue as long as we continue to burn the ancient carbon stored in coal and oil. The question is not whether we will change the climate, we are already doing so. The question is how much we will change it before we recognize the need to change ourselves. Arrhenius's warnings were largely ignored by policymakers and the general public, who were focused on the immediate benefits of industrial prosperity. The 1,920 seconds were characterized by unprecedented economic growth, technological innovation, and cultural optimism. The memory of the Tambora crisis had faded almost entirely from public consciousness, replaced by confidence in humanity's ability to master natural forces through technology and industrial development. This confidence was severely tested by the Great Depression of the 1,930 seconds, which demonstrated how quickly the complex industrial systems that had developed since 1816 could collapse under economic stress. The same global trade networks that had helped communities survive the Tambora crisis by providing alternative food sources now transmitted economic disruption with devastating efficiency. The Dust Bowl that devastated the American Great Plains during the 1,930 seconds provided another reminder of humanity's continued vulnerability to environmental forces. Poor farming practices, combined with natural drought cycles, created ecological disaster on a scale that rivaled the agricultural failures of the frozen year. Millions of environmental refugees once again took to the roads, seeking better conditions in distant regions. Yet even the Dust Bowl was partly a consequence of the industrial transformation that had followed Tambora. The mechanized agriculture that had made possible the rapid settlement of the Great Plains had also made possible the environmental destruction that created the dust storms. Tractors and plows powered by internal combustion engines had enabled farmers to break up vast areas of native grassland, removing the natural vegetation that had prevented soil erosion for millennia. The dust storms that darkened skies from Colorado to Washington, D.C., were visible reminders that human activity could alter regional climate and weather patterns. But unlike the volcanic ash that had cooled the world in 1816, the dust was a consequence of human land use practices that could theoretically be changed through better agricultural methods. Franklin Roosevelt's New Deal included some of the first major government programs specifically designed to address environmental degradation. The Civilian Conservation Corps employed millions of young men to plant trees, control erosion, and restore damaged landscapes. The Soil Conservation Service was created to develop and promote farming practices that would prevent future Dust Bowl conditions. These programs represented a new understanding of the relationship between human activity and environmental health. For the first time since the Tambora crisis, governments were acknowledging that environmental protection might require coordinated public action, rather than simply relying on private market forces and technological innovation. The lessons learned from the Dust Bowl would prove crucial as the world faced an even greater crisis in the 1,940 seconds. World War II mobilized industrial capacity on a scale that dwarfed even the Great War, but it also demonstrated new possibilities for rapid technological development and international cooperation. The Manhattan Project, which developed atomic weapons, represented the ultimate expression of humanity's growing power to alter natural forces. The nuclear weapons tested and used during the war released energy equivalent to massive volcanic eruptions, but concentrated in space and time in ways that had never occurred naturally. The atmospheric effects of nuclear testing would eventually rival and exceed those of major volcanic eruptions. Dr. J. Robert Oppenheimer, scientific director of the Manhattan Project, was acutely aware of the parallels between nuclear weapons and natural disasters. He had studied the Tambora eruption as part of his research into atmospheric physics, and he understood that nuclear weapons represented humanity's acquisition of geological-scale destructive power. We have learned to release in seconds the energy that nature stores over millions of years, Oppenheimer reflected after witnessing the first atomic test. The volcano that froze the world a century ago was nature's experiment with atmospheric alteration. We have now acquired the ability to conduct our own experiments, but with forces that could make Tambora seem gentle by comparison. The development of nuclear weapons also accelerated research into atmospheric science and global monitoring systems. The need to track radioactive fallout from nuclear tests led to the creation of worldwide networks of atmospheric monitoring stations. These same networks could be used to track other atmospheric changes, including those caused by industrial emissions. The post-war economic boom of the 1,950 seconds and 1,960 seconds saw the acceleration of nearly every trend that had begun in the wake of Tambora. Suburban development exploded as returning veterans used government benefits to purchase homes and automobiles. Interstate highway systems connected cities across continents, facilitating trade and travel but also encouraging energy-intensive transportation patterns. The chemical industry, which had developed new materials and processes during the war, found peacetime applications for plastics, synthetic fabrics, pesticides, and other products that required significant energy inputs to produce. The better living through chemistry ethos of the 1950 seconds reflected continued confidence in technology's ability to solve human problems without creating new ones. Television broadcasting brought global events into living rooms across the developed world, creating shared awareness of international affairs but also spreading consumer culture to every corner of the globe. The same electromagnetic technologies that had once carried weather warnings were now carrying advertisements for products that required ever greater resource consumption. By the 1960 seconds, some scientists were beginning to recognize that the scale of human environmental impact was approaching levels that could affect global systems in ways comparable to major volcanic eruptions. Rachel Carson's Silent Spring documented how pesticide use was affecting ecosystems on continental scales. Oceanographers were discovering that human activities were altering the chemistry of the world's oceans. Atmospheric scientists were measuring steady increases in carbon dioxide levels that correlated with fossil fuel consumption. The first Earth Day in 1970 represented a new level of public awareness about environmental issues, but it also revealed how far human society had traveled from the environmental consciousness that had emerged during the Tambora crisis. The problems identified by environmental activists were global in scope but largely invisible in daily life. Unlike the immediate, tangible suffering caused by the frozen summer, the environmental consequences of industrial civilization were accumulating gradually and affecting global systems in ways that were difficult for most people to understand or experience directly. The 1970 seconds oil crises provided a temporary reminder of humanity's dependence on natural resources and the potential for environmental factors to disrupt modern civilization. When oil-producing nations restricted exports, the global economy experienced disruptions that demonstrated how thoroughly industrial society had become dependent on fossil fuel consumption. The long lines at gas stations and the economic recession that followed, the oil embargo, evoked memories of the resource shortages and social disruption that had characterized the Tambora crisis. But the oil shortages were politically motivated and temporary, rather than resulting from fundamental environmental limits. When political agreements restored oil supplies, most people concluded that technological development and market mechanisms would always be able to solve resource scarcity problems. This confidence was reinforced by the continued acceleration of technological development. Personal computers began to transform information processing and communication. Satellite monitoring systems provided unprecedented capabilities for tracking environmental changes and weather patterns. Medical advances promised to eliminate diseases that had plagued humanity throughout history. Yet the same technologies that seemed to provide greater human control over natural forces were also enabling resource consumption and environmental impact on scales that would have been unimaginable to previous generations. The electronic devices that connected people across the globe required rare earth minerals extracted through environmentally destructive mining operations. The satellite systems that monitored environmental change were launched using rockets that contributed their own atmospheric emissions. As the 20th century drew to a close, climate scientists were reaching consensus that human industrial activity was indeed affecting global climate systems in ways similar to, but potentially more severe than, the Tambora eruption. Unlike the temporary cooling caused by volcanic ash, however, the warming caused by greenhouse gas emissions would persist for decades or centuries, unless the fundamental patterns of energy use that had developed since 1816 were dramatically altered. The irony was profound. The industrial civilization that had emerged partly as a response to the climate vulnerability revealed by Tambora was now creating climate changes that could be even more disruptive than those caused by the Great Volcano. The frozen hell of 1816 had lasted for a single year, but the warming caused by industrial emissions would continue for generations. The survivors of the year, without a summer, had demonstrated remarkable resilience and adaptability in the face of unprecedented environmental change. As humanity entered the 21st century, The question was whether modern civilization would prove equally capable of adapting to the environmental consequences of its own success, or whether the lessons learned during that terrible year of cold and hunger would need to be relearned under even more challenging circumstances. The volcanic winter of 1816 had been a natural disaster that revealed fundamental truths about planetary systems and human vulnerability. The climate changes beginning to emerge in the early 21st century would test whether those truths had been remembered, and whether the adaptive capabilities demonstrated by earlier generations could be applied to challenges of humanity's own making.